Assalamualaikum warahmatullahi wabarakatuh. To our beloved lecturer, Technologist Dr. Muhammad Haidir bin Maslan. My name is Muhammad Ammar Bakir and my group mate Muhammad Afiq Daniel, Cik Malisa Maisarah and Ahmad Farouk will be present our assignment for this subject on vapor absorption system for ship air conditioning system. Introduction on the vapor absorption system. The power used to run the compressor motor in a vapor compression system is high-grade energy. For instance, the electric power. However, heat is used directly as a source of energy in absorption refrigeration system. Of course, using heat as much may be better because it avoids the redundant power transformations required in converting heat energy to electrical energy. This vapor was compressed inside the compression system by enduring a large volume change during in the compression process. As a result, the process consumed a significant amount of energy. If a way to increase the refrigerant pressure without changing its volume could be found, the amount of effort required would be drastically decreased. Diagram 1 shows the vapor absorption refrigeration system, but how the system works. There are a few steps in this system. First, ammonia vapor from the evaporator enters the absorber, where it is absorbed by the absorbent, which is water and ammonia, and a strong ammonia solution forms. Second, the absorber's strong ammonia solution is sucked by the pump and transported to the generator. When a strong ammonia solution is fed into the generator, the heating coils in the generator heat the ammonia solution. Third, high pressure vapor ammonia is produced by the generator and passes through the condenser. Then the weak solution remains in the generator and is sent to absorber via the pressure reducing valve. When high pressure vapor ammonia enters the condenser uses cooling medium to remove the heat from vapor ammonia. So following the condenser, high pressure liquid of ammonia enters the expansion valve, where it expands and becomes low pressure vapor of ammonia. As a result of the expansion valve, ammonia vapor enters the evaporator and absorbs heat from the enclosed room, which is to be cooled. Finally, ammonia vapor enters the absorber after passing via the evaporator. As a result, the cycle continues and the enclosed room will be cool. That's all for me.
Hello, my name is Muhammad Afiq Daniel bin Manasir. I will explain introduction of seed system mainly that produce heat. We have a variety seed system like propulsion plant, electric plant, auxiliary system, hull, command and surveillance system, outfit and furnishing, and environment system. However, I will explain more about system that produce heat significantly. For example, engine. Next is propulsion system. The engine, propeller shaft, and propeller are the three basic components of the ship propulsion system. On a ship, the engine is a primary source of propulsion. Most ships have diesel mechanical or diesel electric motor. However, a big naval warship requires gas or nuclear turbine to provide the mass amount of energy necessary. Direct drive engine, diesel electric system, and steam turbine are the three basic methods of ship propulsion. The most popular of them are direct drive diesel engine, followed by diesel electric system. Diesel mechanical system. A single diesel engine spins the shaft directly, and a fixed pitch propeller is used in direct drive diesel system. The propeller rotates at the same speed as the engine. If a variable cam is fitted, reverse thrust may be achieved by running the engine in reverse. The double engine, single shaft arrangement is a more advanced direct drive diesel system. Two medium-speed engines are linked to a gearbox that slows them down for maximum propeller efficiency. Diesel electric system. Diesel electric system could not compete with direct drive diesel system for the most of the 20th century. Diesel electric systems eventually improved, notably in power electronics and motor drive, and their cost decreased as a result of technical advancement. Instead of directly driving the shaft and propeller, the diesel engine provides energy for power plant, which then power the ship's electric propulsion system, which spin the shaft and propeller. With heat source on board ship, a crucial element in the aviation application is the quality of heat source. It has an impact of a variety of factors, including system performance, component size, and cost. The main waste heat source and their temperature range are indicated in Table 2. The temperature of the heat source is the key to determine the quality as shown in Table 3. The heat source is sample incinerator, 850 to 1250 degrees Celsius. Exhaust gas 200 to 500 degrees Celsius. Scavenge air 100 to 160 degrees Celsius. Jacket cooling water 70 to 125 degrees Celsius.
Hi, I'm Marisa. So today I would like to explain about estimated amount of heat could be used for the vapor absorption system. The absorption cooling require heat because it is involved dissolving a vapor in a liquid which is absorbent, pumping the solution to a higher pressure in the regenerator, and finally evaporating the refrigerant vapor from the solution using heat. Water is used as the refrigerant, while lithium bromide (LiBr) is used as the absorber in the most common absorption cycle. Next part, operating temperature. With a single effect, the optimal generating temperature is approximately 200 Fahrenheit. For low pressure steam, which between 15 to 20 psig, is the most prevalent source of heat. Hot water for at least 180 Fahrenheit can also be utilized. In double effect of VAM, the needed temperature at generator is around 370 Fahrenheit. Hence, when employing the process exhaust from a gas turbine or diesel generator, the temperature should normally be greater than 550 Fahrenheit. Next part, efficiency of VAM. Absorption chiller efficiencies are measured by the COP, which is the cooling effect in BTU, divided by the net heat input in BTU. The figure shows formula of COP cooling and COP heating. The last part, required amount of heat source. The required heat source temperature is usually above 80 degrees Celsius for single effect machines, and the COP is in the range of 0.6 to 0.7. COP double effect system is 40% higher than that of conventional single effect cycle, but lower than of conventional double effect cycle while operating at generator temperatures between 127.5 degrees Celsius and 150 degrees Celsius. That's all from me. Next, I will pass to Ahmad Farouk. Thank you.
Hello and Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Farouk bin Ahmad Syamuddin and I am from BMMV S2-1. So today I will present about schematic sketching on our purpose ship vapor absorption system. So in this slide I will present about PT diagram and our schematic view of selected refrigerator cycle. Okay. This is A, P and T diagram of water absorption cooling cycle. So this figure is about PT diagram of water absorption cooling cycle. Low level pressure is used for refrigerant, evaporation and absorption, whereas high level pressure is used for the generator and condenser. The concentration of the solution at each state point water cycle is illustrated in the figure with the reference to the numbering system shown in the figure. At point 1, the solution is reached in refrigerant and a pump forces the liquid through a heat exchanger to the generator, which is at point 3. The temperature of the solution in the heat exchanger is increased. In the generator, thermal energy is added and refrigerant boil off the solution. The refrigerant vapor, which is at point 7, flows to the condenser where heat is rejected as the refrigerant condenses. The condensed liquid, which is at point 8, flows through a flow restrictor to the evaporator, which is at point 9. In the evaporator, the heat from the load evaporates the refrigerant, which flows back to the absorber, which is at point 10. A small portion of the refrigerant leaves the evaporator as liquid spillover, which is pumped back to the evaporator inlet again. At the generator exit, which is at point 4, The steam consists of absorbent refrigerant solution which is cooled in the heat exchanger. From point 6 to 1, the solution absorbs refrigerant vapor from the vapor evaporator and reject heat through the heat exchanger. At point 1, the solution is rich in refrigerant and pumped to force to the liquid through a heat exchanger to the generator. Okay, the temperature of solution in the heat exchanger is increased at point 4. This is our schematic design for the boat. In this situation, the absorbent is water and the refrigerant is ammonia. The process cycle is quite similar to the vapor absorbent refrigeration system. Due to the presence of water in the ammonia vapor ejecting in the generator, the ammonia water refrigeration cycle requires a rectification column following the generator to the condensed water. This is a detrimental impact on the system performance. After the generator, the weak solution combination pushed from the absorber is utilize the condensed water in the vapor. The liquefied water is then returned to the generator. The weak solution mixture is routed through a heat exchanger before entering the generator. Okay, for the conclusion, this study reveals that there is a potential of saving compression power used by employing an absorption refrigeration solution in exhaust gases or in jacket water. In all technical obstacles can be addressed so that fuel may be saved. That's all for me. Thank you.